So what we're going to look at today is the mean and standard deviation, but the mean of the population and the mean of a sample group. So in order to understand all of this, let's just recap. Say this is your population and we have a parameter n being the number of people in that population. Now from that I can then draw out a sample group, and that would be a lowercase n. The size of my sample group would be n, and that would be a lowercase. And don't forget, I can have samples all over the place. The larger the sample, the closer to the true statistics of that group. And so always when you're doing statistics, you've always got to bear in mind that your data could be telling you lots of things that perhaps aren't exactly right. And so therefore we need to have estimators, roughly what this data is going to tell us. If we could look at the whole population, then it wouldn't be an estimate, it would be the true value. And that's kind of important. They would be called the parameters. Let's assume this is the parameter. So this may be the age of people in a playground, and I wanted to find out the average age of these children in the playground. And I also might want to work out their standard deviation or their variance, which is the measure of dispersion. To do that, because this is the population, the mean I'd write like that, mu, and I'd add up all the values, and the values would go from the lowest case of value, 1, the first one, to the total in the population. And then I'd divide that by n. So in order to do that, I'd get my calculator out. And this is all very straightforward, and most of you know how to do, well, you all should know how to do this. If I summed all of that together, I'd get to 20. And so that's 20 divided by 5 is 4. So the mean value here is 4. And what's interesting about that is if I was to then look at the distances away, I've got plus 1, plus 1, plus 1 away from the mean. Here, minus 1, minus 2. And notice how they counteract each other, which is why we get that right in the middle. The mean is right in the middle. Now let's look at the variance. The variance is the amount of spread we have from the mean. So we would use that test statistic. We'd look at first the variance, how much it varies, and then we square root that to find the standard deviation. We measure this using this tool. We start with the first value of 1 all the way up to the last value, n. And we take each value in turn and we take it away from the mean value and then square that. And the reason we do that is the fact that if I was to draw a line of best fit like this, then what we're looking at here is how far away these values are from the line of best fit. And if I were just to sum the differences without acknowledging that this could be a minus and this could be a plus, we'd end up with 0. And so therefore what I need to do is I get these minuses and I square them, and that's the sum of the distances away. And then what I would do is I would divide all of that by the total number in the population. And so that's how I'd work out the variance, the population variance. And our standard deviation, therefore, would be the square root of our variance. So how I do that is I take each value, let's show you. So I've got a 2 and a 3 and a 5. I know the mean value here is 4. So I take each value and take it away. So here I'd get 2 and then I'd square it. So it'd be a distance of 4. This is a distance of 1, square that. This is a distance of 1, square that. And don't forget, I have 3 of these. So I'd have 3 of those. So if I worked out the sum of all of these values, so this is the sum of each value taken away from the mean and squared. If I did that, I'd have 3, 4, 6. That would be a total distance of 6. And to share that, what's the average distance? I would say 6 divided by the 5. And that gives me 1.2. So the variance would be 1.2. And therefore, the standard deviation would be the square root of that, equaling 1.095. And that would be our population parameters. The mean would be 4, and our standard deviation would be 1.095. In the next slide, I'm going to say, well, what happens if this data wasn't the population, but this data represented a sample? What happens then to this data? So watch the next one.